Question 8 starts off with dynamic programming. So basically, there's this person designing a plan and they want to maximize the profit. Each of these numbers is in thousands, and there's a bunch of different strategies here. And here's the cost of each strategy. So the first thing that I did is I wrote in all the numbers onto the diagram, and then I did dynamic programming on the diagram because it's nice and easy to do it that way. So again, I'd recommend you do this in pencil and then go over it in blue pen so that you can see it against the black lines. Go over it in pencil, because if you mess something up here and you have to scribble it out in pen, well, there's not a second copy of the question unless you ask for a second exam paper, but that is not ideal. So I'd recommend that you do it in pencil first. So x to a, we're going for -11. X to b is -13, and x to c is -9. This is where it gets very messy. A to D is 5. A to E is -2. A to F is -5. -5, it's hard to draw upside down. B to D is 7. B to E is -3. Try to write them parallel to the lines that you're using so that you can tell easily. And then B to F is 4. C to D is 5. So C up to D there, that's 5. C to E is -4. And then C to F is -1. Now I have to do it all again. D to G is -5. D to H is -3. And then D to I is just 3. E to G is -2. E to H is 5. And then E to I is 6. Then F to G is 4. F to H is 3. And F to I is 2. And finally, G to Y is 6. H to Y is 5. And I to Y is 7. So now we can do dynamic programming on this. I'm going to get rid of this because we know what the profit and all is. And now the question is asking us to use dynamic programming, or it's also sometimes called Bellon's principle of optimality, to calculate the business plan that maximizes profit. And it says show work. Remember, on the instructions of the exam, it says you can show your work on the given diagrams and networks, so that's all good. So I'm going to get rid of this to save space. And now let's start dynamic programming. So this shows the decisions that we're trying to maximize, or in other words, get the biggest number possible from X to Y. So we're going to start off at the end in year 4. So let's have a look at all the values for G. Well, there's always only one, so it's either 6 to Y, and that's the only possibility. Here it's 5 to Y, and that's the only possibility. And here it's 7 to Y, and that's the only possibility. This is where it gets interesting. So for D, if we decide to go to G, that'll be 6 minus 5, we'll have 1. That's going to G. Move that up a bit so we have extra space. If we decide to go to H, we'll have 5 minus 3. That's 2 if we decide to go to H. And then if we decide to go to I, we have 3. We have 7 plus this 3 will give us 10 if we decide to go to I. We want to maximize our profit, so we'll go with 10. Then for E, we go up to G would be 6 minus 2. That would end up giving us 4 if we decide to go to G. If we decide to go to H, that would be 5 plus 5 is 10 to H. Or it's going to be 13 to I believe. Of course, we want to maximize 13 to I is our best bet. For F then, if we decide to go to I, we'll have 9 going to I will be our profit. To H, it'll be 3 plus 5, which is 8 to H. And then from F up to G, that's 4, and 6 is 10 up to G. So that's going to be our best one, of course. Then we move on to the next stage. So here we'd have 15 if we decide to go to D. So 15 if we decide to go to D. If we decide to go to E, we'll have 13 minus 2 is 11 if we decide to go to E. And if we decide to go to F, we'll have 10 minus 5 is going to be 5 going to F. Of course, we want to choose 15. For B, we're going to have 7 going to I is going to be 17 if we decide to go to I. 13 minus 3 is going to be 10 if we decide to go to E. And for F, it's going to be 4 plus 10 is going to be 14 if we decide to go to F. Of course, we want to go with I in that case. Wait, I? There's no I here. Why did I write I? This is going up to D. I wrote I because I could see the I up there. That's 17 going to D. We want to do that. And finally, for C going to F, that would give us a 9 if we decide to go to F. If we decide to go to E, it'll give us 13 minus 4 is 9 going to E. And if we decide to go to D, it's going to be 5 plus 10, which is 15. Going to D, of course, that's our best bet. Now, finally, we look at our options for the very start. So we'll have 15 minus 11, which will be 4 if we decide to go for A. If we decide to go for B, it'll be 17 minus 13, which is also 4. And then finally, if we decide to go for C, it's going to be 6. If we decide to go for C, that's the biggest profit. That's obviously the best one because 15 minus 9 is 6. Therefore, 6 grand is how much they'll make. But let's just look at the question again. It asks us to calculate the plan that would give the most profit. So let's have a look. So we want to go to C. So that's this way. Then we want to go to D, which is up there. Then from D, we want to go to I, which is down here. Then from I, we want to go to Y. So the plan that's most optimal is we go from X to C, then from C to D, then from D to I, as we have up there, and then finally from I to Y. And that will give us 6,000 euros profit. So instead of calculate the plan, that's why I did both. I wrote the plan and the profit. That's the best decision. 6 grand is just coming from here. We got a 6 to C is our best one. And then it said that represents cost in profit in thousands. So positive 6 is a profit of 6,000. Then it asks us to state a difference between Bellman's and principle of optimality and Dijkstra's algorithm. There's a few of them. So one of them that you could say is that Bellman's is greedy, or isn't greedy rather, but Dijkstra's is. Or you could have also said Bellman's. I'm actually going to type them because it's a lot quicker. You could also say. So there's a lot of possible answers. You could say greedy versus non-greedy. You could also say that the Bellman's breaks the networks up into stages, but Dijkstra's doesn't. Or you could also say that Bellman's works with positive and negative weights, but Dijkstra's only works with positive weights. Just any valid difference between the two should be fine. Then for some reason part B is dimensional analysis, even though it had nothing to do with part A, which is kind of weird. But basically we're given this formula. There's force, mass, displacement, and angular velocity. Dimensional analysis show that's the same units for displacement. So let's start off by saying the unit. So force is kilogram meters per second squared. Displacement is given by meters. Mass is given by kilograms. Now just be careful because meters and mass, same symbol. Now omega squared, it's actually 1 over t. It's actually t to the power minus 2. It's not radians per second. It's actually just per second squared, which you'll see now. I'll show you. So they asked this last year as well, so they're probably trying to catch people out because this is one of the hardest examples. The reason is because angle in radians is given by, obviously, the arc length over the radius. That's meters over meters, or in other words, an angle in radians actually doesn't have any dimensions because it's meters over meters. So that means omega is meters, or sorry, it's no dimension, because remember the angle has no dimension over time. That means that omega squared is just 1 over time squared, or time to the power minus 2. I'm just writing them as negative exponents to keep it consistent. So that's the reason why it's not radians per second, it's just per second. And then in this case, it's squared as well. So now we can sub into our formula. So we have the square root of 4 is a constant, doesn't make a difference. We have kilogram meters per second squared times meters over meters for displacement over mass, which is kilograms, multiplied by seconds. Sorry, I wrote T for time. I wanted to write S for seconds per second. So we'll have S to the power minus 2. So you can see the kgs will cancel on the top and bottom. S to the power minus 2 cancels on the top and bottom. We're just left with the square root of meters squared, which is equal to meters, which is equal to, I'll just write the word meters, just because M can sometimes mean mass, make it very clear, which is the unit of displacement. I don't know why they gave a whole A4 page for that, but that's how you do it.